Welcome back. Here we go for the next one. In the first video I talked about how the sine, cos and tan work, where did the words come from, what happened. In the next one talked about how to do questions using sine. In the next one talked about how to do the questions using tan. And tan comes from the line that touches a circle, which is called a tangent, and we shorten it to sine, to tan. Now on these ones it's the same diagrams again while I've got them drawn up. And instead of calculating the side over here, going to calculate the side over here. Different sides on the triangle. Most people are okay that that's a hypotenuse, and we abbreviate it HYP for hypotenuse. On this one, of course, this will be the hypotenuse as well. So let's have a look at what we've got. The side that's here next to the 20 degrees, next to is the word adjacent. Of course, we abbreviate the word adjacent to just being ADJ, or even just to the letter A, because it's obvious that means the adjacent, which is next to it. So both of these are next to the 20, but that one's obviously the hypotenuse. So going back this way, next to the 20 is that. If you watch the other videos, I explain it more. So historically, people wanted to turn a right angle triangle into a fraction, comparing this length with that length using 20 degrees. So if I said we were using 20 degrees, let's compare the length of that as a fraction with the length of that as a fraction. So what have we actually compared? We've compared the length of the adjacent with the length of the hypotenuse. And a lot of people write that as A over H. So remember what it is. Instead of saying using 20 and the 8 and those things there, someone come up with the word or the concept of cos. It's actually the co of sine. So it actually comes from the word sine up here, but it's the complementary angle of sine. So it doesn't mean we can't use 20 for both of them, but the relationship between the numbers is complementary. We don't need to know about that. So in this case here, I should have really written that as the adjacent over the hypotenuse. A lot of teachers will insist that every single time you write the formula down, because they're trying to brainwash you, and they know from experience that the kids write it down normally do better than the kids that don't. But there's an awful lot of kids who can just see it in their head and they have no problem. So let's have a look at it. We're going to replace the theta by the angle that we're talking about. So if the triangle happened to have other angles written here, like that one was 70, you could do the question differently. But we're not, and also the 70 might confuse you because it's got extra information written there. So we're not talking about the 70, we're talking about the 20, because those two numbers, by the way, have to add up to 90. That's why I talked about the co or sine. So the cos of this case 20 degrees is going to use the adjacent, which is next to the 20, not that one because that's a hypotenuse. So we want to find the length of the side that's got the x on it, and the hypotenuse is 32. Back to equation solving, probably seen me do it a few times now. How do you get rid of a divided by 32? If I multiply this side by 32, I multiply that side by 32. Then any number will go into itself. A denominator will go into the numerator. Once, when I was at school, we were made to write over 1 so you could see that you've got a numerator and a denominator. Not that fussed about it these days. You can get away with people understanding that 32 into 32 goes once, so that is just 1x, which you can write as x. So to balance up the scales, to balance up the question so it works, so you can use the correct storage on the calculator. Now we can go 30 times by the cos, and again make sure that your calculator says DEG for degrees. Mine says degrees, otherwise all your answers will be wrong. And we get 28.2. Let's see how accurate I am. 28.2. No, I just realised that I actually made that as bigger than 28.2. I'm actually going to do with that. I'm not going to change the video. I'm going to leave it as is, because this is actually 32.5. I didn't want to use 32.5, but I think I should. I think that would be a good example, because in real life, all the numbers are not necessarily very nice numbers. So I'm going to leave that as 32.5, and that is 32.5. How many times does 32.5 go into 32.5? Just the ones. So there's my ones. I'm going to get rid of that one. I'll pick up my calculator again, moment of the truth. I go 32.5, this will be interesting, by the cos of 20, and I get just over 30. So that's a more accurate answer, and you can see by looking at it here it's 5, 10, 15, 20, 25, 30. So you can use that to calculate the numbers. And if I want more accuracy, then I need more decimals and all that sort of stuff. By the way, when I teach this, there are so many ways to teach it. For a while I used to teach it, just tell people what sine is and sine alone. Sometimes I taught people just do tan and tan alone, and then teach them all the equations that go with it. These days I walk in and I just deal with a situation where it all looks the same as an equation. I'll show you what I mean by that. So on the second one here, the angle is 30 degrees, so we're talking about an angle of 30 degrees. There's the hypotenuse, the other next to, adjacent to is that one there. So I'm going to replace the word adjacent by the x, and then have a look at the hypotenuse and replace it by the 35. Now have a look, all of the three types of examples I've shown so far have x on the numerator. So instead of teaching you different equations, I want you to learn more about trig before you do the different types of equations. So we're looking all the time now when we're finding or calculating the denominator. So we're calculating the denominator. That makes the equations all work the same. So if I times this side of the equation, I could write it here by the way, it wouldn't matter if I write it there or at the back, if they're going to be squished. I write it at the front, and then the 35 goes in the 35 once, so that's going to be x. Pick up my calculator, of course make sure it's set on degrees, and I've got 35 times by the cos of 30 degrees. And I've got 30.3, so again fairly accurate. I could go more accurate if I wanted to and figure out what it really was. So what have I got? 35 times the cos of 30 is 30.3. So we're talking about x is about 30.3 centimetres. So it'd be interesting to see how well I drew my diagram up and check it with that. I'll leave it to another video to talk about the different situations. I might even do a video where I do all three of these in one. You can get the hang of that first before we go to the rest. Thank you.